Right, so not in the same league as yours, Luina. Sorry if I mispronounced your name, but this is a much simpler project, and it's really a tale of failure and how to learn from the failures. So when you're prototyping something, then basically what I'm trying to say is, and the theme for this presentation is you got to expect things to go wrong. So I've got a very simple irrigation system. This is where it all started. I've got a little timer which runs off a tap, and it sends water all around the plant pots and my hanging baskets. And it's on for usually about 30 minutes, 20 minutes at the moment, as you can probably see from the picture. And it sends water via very thin 5 mil piece of tubing all around the garden. Um, it's it's very simple, but it's got lots of failure points. Even down to the batteries in the timer, they won't last the whole summer, and it can either jam on or jam off. And this summer it jammed on, so you end up with water leaking everywhere. So I thought it might be an interesting project to see if I can monitor the moisture levels in the plants. So I did a bit of research online, and I found on Pi Hut there is a project called Raspberry Pi Plant Pot Measure Sensor with email notifications. It's an absolutely ideal. Last year, my irrigation system failed, and you know the plants will keep going and look okay for a week, 2 weeks even, and then they're dead. So I was looking to build something to try and protect them. Just a bit of fun. No real reason, just a bit of fun. So this module, it uses some pretty cheap sensors which you can get from Amazon. There's 3 sensors for fiber. So you get 3 sensors, 3 hygrometer modules, and the modules have got digital and analog outputs. So thinking here is I'll just connect them straight to the GPIO ports on the Raspberry Pi Zero, which I had. So that worked. I made the leads a lot longer than the ones you can see in the top one. So I've got a module sort of in the middle of the 3 hanging baskets, and it's connected through fairly long leads, and it's plugged into all 3 of them. And at the top of the modules, this is where the sensors plug in, and then you've got a potentiometer where you can actually set the trigger level, and when they get too dry, the output goes high, and that sends an email. The Raspberry Pi is connected via Wi-Fi, and it's just outside the office, or my home office, so it's got good Wi-Fi signal. It worked fairly well. Well, it worked well to start with, but it's really fiddly because I've got to go outside, stand on a step ladder, and adjust the potentiometers a little bit when I think it's getting a bit dry or it's not triggering enough or triggering too soon. So it's really fiddly. So at that point, I'm thinking, right, so how do I fix this? So I could connect external pots to the hygrometer module, so I don't have to stand on a ladder, but that's a terrible idea. Keep adjusting the potentiometers over a few weeks until you get them right. And what I went for was actually something else. As I said, they got digital and analog outputs. So use the analog outputs, and with the additional of a little board called a RASP-IO Analog Zero, that just it's like a daughter board that plugs on top of the Raspberry Pi Zero. It's the same size. Plug it straight into the header, and you've then got 8 analog inputs. And as you can probably see, you got a bit of a prototyping area as well, which I ended up using because I had to adjust the signal levels from the sensors a little bit. So stage 2, Stage 2, I've got a voltage output depending on the moisture. It was relatively stable as well as moisture output, and but I taken a lesson from the last lecture. Maybe what I should have done is actually taken 10, 12 measurements over a few seconds and then taken an average. Would have been a little bit more consistent. But they were pretty reliable. So with stage 2, now I didn't have to go and climb the ladder. I can just SSH into my Pi 0 over the Wi-Fi, address the trigger levels, and it was then working fairly well. So everything was going fine. I put it in a box, a nice waterproof box. You can see the moisture sensors are down at the bottom of the box. At the top, we've got the Pi 0 with the analog to digital converter at the top. Plenty of room, and yeah, it worked well. Except I got to feed 5 volts to it, and there was quite a long, maybe more than 10 meters, maybe even 15 meters of bale wire connecting the power supply, which was indoors, obviously, because I didn't want to bring mains to the outside. And the problem with that was the 5 volts was more like 4.7 volts by the time it reached the the box outside. So again, what would you do? So I suppose you could run a cable to the box. Using thicker wire is a much better idea, but you'd still have a voltage drop. Increase the power supply a little bit, 5.3 volts, to make it, to compensate for the drop, but that means making a variable power supply. Again, I did something else. So stage 2 fix was actually back to Amazon again. There's a 5 volt regulator, voltage regulator module for $3.99. It's all wired up, and you feed in anything up to about 30 volts, I think, and you get a nice steady 5 volts out. Very simple, and you can even feed. You can probably work out by the bridge rectifier at the front. You can even feed AC into it. So little smoothing capacitor, voltage regulator. And you got a nice steady 5 volts. So I changed the power supply from a 5 volt one to 12 volt one, and started feeding the 12 volts around the side of the house, and I got nice steady 5 volts in the garden, in the box. So yeah, that was working really well. I did lots of little tweaks to the software, for the emails and to the the messages that were sent out, and everything was working fine, and it was my little summer project. And then one day I get low moisture warnings. Cool, it's working. My irrigation system and all the fiddling, it's all paying off. Something's failed. It said this is a moisture sensor I got. Yeah, the center hanging basket was down to 14%, 14.3%. So you go and check all the pipes, and it's fine. It's moist. So okay, something else went wrong, and the problem was pretty straightforward. You see these moisture probes. It took about 2 weeks to electrolyze all the copper off the probes. The thing is, the probes are on 24 hours a day, taking measurements every so often, but there's DC across them all the time, and there's not much current. We're talking microamps running across it, but there's not much metal to move, and it basically just what it did, it just took all the copper off one side. So what do you do? Well, it's give up, get new probes, which I did. I went to the manufacturer and said, yeah, your probes are a little thin. This is what happens after a couple of weeks. And they very kindly sent me some new ones. In the meantime, I made some thicker probes from bits of copper, which I tinned. And that's just to replace the probes, and they're doing fine. But the fix again wasn't that. The fix again was something else. The fix was get another module, again from Amazon, there's a plug here somewhere, and just to turn hygrometer modules on once an hour, long enough to take a measurement, and then turn them off again. And that worked really well. I mean, what I could do is take some average measurements this time, and maybe to get something a bit more stable, but it's been working absolutely fine. So I just turn them on. That turns on the, the three hygrometer modules all at once. And I ended up with this project. So this is the final version of it. So we've got the Pi Zero over here with its analog to digital hat sitting on it. I've got the power supply, which has given me a nice steady 5 volts. This is my hygrometer modules. They're actually hardwired in. I took the header off as well in the end and just soldered them straight onto Vero. And then this is my relay. I also added some LEDs, these 3 yellow LEDs onto it. Because I'm only taking a measurement once an hour for perhaps a second or so, these LEDs will actually reflect the status of the measurement at that time. So I'd end up with the yellow LEDs on for the whole time, as long as the last measurement was good. And at the top, I've got a green LED, and that just tells me that I'm connected to Wi-Fi. So every 10 seconds or so, I think it is, maybe 30, it does a ping to Google. If it gets an answer, it goes, yeah, I'm still connected to Wi-Fi. So that means now I have the box, which is just under the awning, under the front door, with lots of pretty lights, which I like. And just a quick glance up, I can have a look. See, I've got 3 yellow LEDs, they're cool. I've got green LED, yeah, I'm connected to Wi-Fi. And all the other pretty ones are just part of the boards that come with it. The little white one at the top I added as well, because I like lights. It's all pretty bright. I mean, that was taken at night, it's not quite that bright, but it also gives some credence to my dummy CCTV cameras, which I've got outside. Maybe a little bit of deterrent there as well. So I could take it a little further, but this is where I am at the moment. I get the emails once a day, which is the text on the right saying, yeah, the left, center, and right hanging baskets are okay. There's also an ambient light LDR on there, which sends me a level once a day. So what I could do is take it forwards is I could post it up to Azure IoT, post the readings taken once an hour, and then make some pretty graphs. I could also play around with Azure AI to see if AI could actually detect any patterns in the irrigation and possible failures. Could take it that way. Could also correlate the ambient light readings with the online weather. Could do that, or just call it a day and have a beer, which is what I'm doing now. So my message here is failure is not failing. It's not failing. It's just refusing to get up. So when you fail, fine. It's just a matter of moving on and learning from your mistakes. Okay, any questions that people might have about this? I'm quite happy to share the code online, by the way. Yeah, like the last presentation, it's working. There's still a few tweaks I'd like to do to it before I share it, and need to anonymize some of the things like my email account and stuff like that. But if anyone's interested, I'm quite happy to share it.
So I do have a question about those those relays, that relay you're using, has that been 100% reliable, or do you find it, you haven't had to replace it at all, have you?
The relay,
Yeah.
very, very reliable. It's not been a problem at all. In fact, you get 6 in the pack anyway for £8. No, it's been very reliable. It's quite a high current relay. It's a lot more than I need. I'm only turning on a few milliamps.
I think they've got thousands, tens of thousands of cycle life in them. I use a few of them, and they're very good.
Yeah, I just wasn't sure Why did you choose a relay over a transistor, for example?
Just for simplicity, because I could have done just put a transistor on, but just for simplicity, the transistor would have need to turn on the positive supply. I mean, I could do it. I mean, background's electronics. It was just simplicity.
I do know that relays make a satisfying clicking noise.
Yes, they do. Yeah, and
Don't
it's
get
got
out of the transistor.
yeah, it's also got some diodes across it at the contacts as well to stop the spikes. So I did have a check of that first. But yeah, I mean, it just works really well. You can actually get the relay to trigger off a high input or a low input just by switching that thing over. And I thought, yeah, okay, it's just for the sake of playing with it, which is what I was doing. That was the easiest way of doing it.
So how's the corrosion now then, now that you've done this?
Well, what I've actually done is I took some, what do they call it in plumbing? Olives, isn't it? Those rings that you put around pipes.
Yeah.
And made a cut, straightened them out. So I've now got something, sort of that sort of size, and tinned them, and they haven't budged at all. It was my temporary fix. I've got the new ones. I've got the new modules, which they sent me kindly. But yeah, why? I wasn't going to fix it until they had a problem. See, I mean, you get 3 of these hydrometer modules and 3 probes, which they kindly sent me, but I haven't bothered to replace them yet.
Yeah, so I wasn't sure how much of the corrosion is just natural from essentially having, sitting in an electrolyte. Even if you don't apply a voltage, I wasn't sure if you'd still have corrosion.
Yeah, I mean, if you look at the corrosion here, you can see that one side basically moves to the other. And you can see that it's good evidence of electrolysis. So it's just moved from one probe to the other. So yeah, if I was to do it again, I probably wouldn't use those probes because there's not much metal in it. But using the just bits of copper, which I tinned, to stop the corrosion.
Yeah, when I've used these before, I used something similar before, and I found that it was really hard to get a good reading because the soil it was in was quite loose. So I don't know how you dealt with that.
By pushing it in quite a bit.
Okay.
So they're sitting a good 5-6 centimeters into the soil. So that you're sort of averaging out the resistance across it. Also, what I found was, the closer you bring your probes, the lower the resistance. That's going to change the value. And what I did in the code was I basically looked at the way the values change throughout the day, and didn't actually rely on a particular percentage to say it was dry or getting more wet. Each probe had its own actual trigger level.
I wonder if you could use perhaps something like the weight of the basket as an indicator of moisture.
That would be a very reliable way of doing it, of course. Yeah. And I've toyed around with the idea of I've got some herbs, which I have on the kitchen window. And you have to water them every day or so. And a very good way of measuring whether or not they run out of water would be just to put I forget what you call them, but those gauges that can measure basically pressure.
A strain gauge maybe on
strain gauge, yeah. You can get cheap strain gauge and basically use it as a plant pot. And then that would be the easiest way of doing it. The other way you can do it, of course, is you have 2 dissimilar metals sticking in the basket, and then a little sensitive voltmeter. I've tried those in the past. They're useless. They last a couple of weeks, and they stop working after that.
What about, sorry, Paul, what about, as Ram put in the chat, and as I was thinking as well, there's capacitance versions you can get.
Oh, yes, there are capacitive versions. And I mean, there's plenty of room for improvement. I found by using basically the strips of copper, pretty substantial copper, and tinning them, I've had no corrosion at all. Looking at, they've been in there for several months now, and I've taken them out this weekend actually, and look, they're absolutely pristine. So I would probably go along for just making your own probes and take your own average measurement. Unless you actually have to know that it's going to be, 40%, 60%, whatever the water level is. You could take it. You could just make your own probes, I think.
If you're really lazy, you just pick one of these bizarre things up from China.
Yeah. What have you got there? You got some probes.
It's a probe which is actually a Bluetooth probe.
Oh, right.
So if you're really lazy, you don't have to wire anything together. You just pop them out in the garden, and they're BTLE.
Yeah.
Just do this low frequency send. Unfortunately, as soon as you talk to them, they bind to the address that they talk to, so you can't get multiple devices listening to them, which was the original plan with these.
Yeah.
But they're interesting me though, because it's just two studs on a non-metallic spike. I have no idea how it actually measures, but they are quite interesting if you can come across them.
That's perhaps the capacitive ones that someone was mentioning.
Could be, but, yes.
Yeah, but unfortunately, I haven't got a picture of the hanging baskets now because they're basically, they've passed their prime now, but it worked. The only thing it did tell me was that the battery in my timer had died, and the water had come on, and there wasn't enough voltage left to turn it back on again. So it did actually do their job. Right, is it beer time, folks?
Any other questions? One last question, anyone?
I was going to say is Paul's plan for next season to get the watering system wired into the automation as well, so rather than just be on a battery timer.
Yeah, it's not too bad. It's cheap and cheerful. It's not on a timer per se. It's got an ambient light meter on it, so you can set it to come on when it gets light or when it gets dark. So that's pretty reliable as far as timer. It runs on 3 AA batteries, and it's not going to last the whole summer.
One problem with using weight would be that as the plants grow, the things get drier.
Yes, yeah. And also, as they grow, they're going to dry out quicker, aren't they?
Yeah.
Yeah. I think it'll be quite fun actually to connect this to Azure IoT and actually take some measurements and send them up there and just see how it behaves over the course of months. I think it'd be quite a fun project to move on that way.
Cool.
You could race various sensors in there and see how they do in the one bowl.
Yeah, could have several. Yeah, I mean, I've got 8 analog inputs, so I could actually put some different types of sensors on as well.
Cool. So let's grab a beer, have a quick break.
Okay. Well, thank you very much.
Paul,
for your
very
time.
interesting.
Very much. Very, very good.
Thank you. Cheers.
Thanks. So we'll take a break. We'll be back at 5 minutes to the hour.
Sounds good.
Yep. Let's just say, 10 minutes. Let's just meet again at 9 o'clock, 2100.
Okay.
Okay.
Okay. Thanks very much, Paul.